Good afternoon, morning rather. Clearly I'm mic'd, I'm on the screen. My name is Jesse Willett. Welcome and thank you for coming to my presentation on our team's migration from a single Postgres to a sharded Citus Postgres. Welcome. Before I go much farther, I know many of you in the room, but I'm guessing there's up to 9 people here that might be making a decision to migrate onto Citus in the near future. Anybody who's going to do that or considering doing that, could you raise your hand? Well, this is very interesting. 1, 2, great. So this is mostly for you. I would welcome the 2 of you to ask any question that you have, everybody, but especially you two. Raise your hands as soon as you feel like you have a question. I speculate that your questions are more interesting to the point of this talk than the last couple slides I might have near the end. So go ahead and bring it on as soon as you have it. Okay, so who are we? ProsperWorks is a multi-tenant CRM as a service. We're a cloud-based offering. We integrate very closely with G Suite applications. And the short form is we extend your Gmail to keep track of all your contacts and give you a Rolodex of information about your interaction with them historically every time you're dealing with a customer. And our marketing team has come up with the mission statement. Our mission is to help businesses sell more with a CRM that teams actually love to use, and we're making CRMs easy to use. ProsperWorks was built with 3 basic principles in mind: keep it simple, show what matters, and make it actionable. So that's we do succeed at all those things, and I love doing that. But as an engineer, I'm not a CRM user, so I'm here to talk about how we do it, not exactly what we do. And this talk is the story of how we migrated our primary store from a single Postgres to a sharded Citus. It's going to be a tactical survey of our implementation, some postmortem notes about what went wrong and what we might have done differently. And I don't have a drop-in gem or a magic solution that you can all just throw into your project at the end that's going to solve all this stuff for you. But hopefully you'll have a strong and confident sense of what issues to watch out for as you move forward. I am a server architect who at ProsperWorks focuses on scaling our storage layer and our asynchronous workloads. And I've worked on lots of different stacks for storage with different concurrency controls over the last 10 years, including what we're doing now, PG and PG plus Citus over Ruby on Rails at Postgres, Mongo with Doctrine for the ORM in PHP at Lyft, and Membase, Couchbase family of simple string key value stores with no concurrency or atomicity or guarantees of any kind at Zynga. Well, no. Actually, we always called it Membase, and we had been working with it from before the fork and before they called themselves Couchbase. But it was conceptually the same thing, but it was always sort of our own build. And I believe in that stack. I'm not recommending it to anybody, but you can actually build complicated, robust things at a reasonable pace that scale like nobody's business and very cost effectively with that stack. But of course, it's a totally different universe from what we do here. So I've also built strategy games, text search engines, and games for feature phones. I have a storied career. I am bragging and stealing work that other people did at ProsperWorks and for ProsperWorks. So this is a story of a lot of people's work. The list of the names is here, but I'm going to call out especially Gerald Coulter-Mistele, who we called our transaction czar, and he did the bulk of the Rails work and the planning of how we were going to manage things. And also Lucas, who you may have already seen present some at this session or in previous conferences, who really saved our bacon a half a dozen times and put enormous numbers of hours in from the site side to help. When we messed up, he swept up. So thank you, Lucas and Gerald, neither of whom is in the room. So at the end of Q3 last year, we don't have an elite problem. We don't have petabytes of data in a Postgres. We don't have millions of lines of code in our Rails server. We only had 141,000 lines of live code and another 70,000 lines of test code, 65 tables in contemporary Postgres, or close to contemporary at the time, well, a little old, serving 81 Rails models, only 0.7 terabytes, but it was growing at 5% per week, and we have ambitions for that to become an elite size. And we were anxious about it becoming an elite size because we were cautioned by our hosting vendors that beyond 1 terabyte, performance could start falling down. We had a managed Postgres, a hosted Postgres that we were pretty happy with, except for its limitations. It maxed out 120 gigabytes of RAM and 1 terabyte of storage. Mentally, we were in a place that wasn't very happy. We were constantly putting out performance fires with that database. We were funding work to move large volumes of relatively cold data out of Postgres and off into S3, which is effective use of machine resources, but not an effective use of engineering time. We were afraid to add too many indices because of on our larger tables, because even if the user experience on some queries was suffering, we were worried about knocking ourselves up into the danger zone beyond 1 terabyte for our total storage size. And we're not worried that much about write performance versus read performance, but we want read performance to be attractive. But we were afraid because of size to add indices that would have improved UX, and that's not pretty. And we were only using Rails' least common denominator DB abstraction. So I am not speaking to you as a Postgres expert. In fact, until a year ago, we were actively resisting learning Postgres-specific details because we didn't want to sort of like stumble outside of the safe little pen that we were using in Rails. We violated Rails abstraction in a dozen other ways, but we didn't want to add one more here until we needed to. Then by the end of Q1, we had grown another 10,000 lines of code, of live code, and another 20,000 lines of test code. We had another handful of tables. We had upgraded. We were on Citus. We had double the data volume, but it was only growing less than half as fast because of some of those efforts. And we're on Citus Cloud, and we're very happy there. We have 64 shards. We have a 60 gig RAM coordinator and 6 61 gig RAM data nodes and 3.8 terabytes of available storage, which we haven't even gotten to half of. And without even going off the menu or asking for any special help, we have 10x apparent growth over that limit still, so 20x over our current use. We don't worry about database performance most months. When we do, it's one really bad query. It's not the aggregate throughput of all the queries stomping on each other at once. We're generous with new indices when we have a short-term performance woe. We now optimize at leisure instead of in a crisis. Actually, we spent our time solving other problems since we did this, so that's a win. And we've really embraced Postgres-specific features and advanced functionality both in Citus and with Postgres, and we're being ourselves experts in this specific RMDB and not in Rails' weakened generic RMDB. The level of effort that we put into this was 3 dev months for Gerald, constraining our Rails code to be Citus ready and to follow all the rules that were necessary for Citus before we were actually on Citus, because we wanted things to fail hard and fast and for individual developers. I spent 1.5 dev months patching our data model, backfilling shard key columns, purging dead data, and preparing index creation scripts, massaging the database extensively with Gerald massaging the code. Our migration itself was a 19-hour day for 8 people. We had a whole bunch of devs put a dev month into the next week after we were live, banging out whack-a-mole on a few more perf problems the first week. And then another 3 dev months have scattered over the 6 months since then on various non-crisis kind of tweaks to be better using Citus, which I think was actually a big win because we had anticipated building our own sharding solution a 1.5 years ago, and that was not going to take 9 dev months. I know dev months are a lie. I do not believe that dev month is a viable unit of currency in planning, but I think it is an accurate measurement for past outcomes. So I apologize if I've stressed any of you out by using that phrase. Okay, so our implementation plan was it was 2-pronged. We like having our code fail hard and fast for our developers when they go outside of the safe zones. So we imposed a lot of requirements on our own code that were beyond what Citus would require for you. And later on, you're going to see me describing some of those requirements. Citus gives you a lot more liberty than what I'm going to describe. We wanted to confine ourselves to what we knew we could make safe and predictable and easily explain to our entire team. But we demanded that a shard key column be declared explicitly in our Rails code for every model. We declared shard key values in our logic flows. Instead of just letting low-level utilities use them, we sort of like declare them globally for this entire request or this entire job, and we would require that in some cases. And we monkey patched the Rails to add checks and failures and warning and logs whenever we broke one of our self-imposed rules. I think that strategy worked, and I recommend it. We also unnecessarily updated our data model to be ready for Citus. We had to add key columns, shard key columns to any table that lacked them. We had a lot of transitive associations that didn't have a direct reference to our master shard table. We had to make sure that those foreign keys were valid and had no nulls in them, which in the case of legacy, there were nulls, and we had to go out and backfill them. I did an extra pass to more aggressively purge dead data than we would normally to try to bring our data volume down to minimize the migration time. I also accelerated the effort to migrate some data into S3 to reduce the physical volume of data that needed to be migrated into Citus, again, to reduce the downtime on our migration. And we had to do some modern other kind of schema backfills. Once both of these things were ready and we had done extensive testing and we had done all the sort of offline and dry run testing that we could, it was a pretty straightforward. App goes down, modify the schema into the new database, run pgdump tpsql, and create new indices in the new database and bring the app back up. Sadly, we did not have a zero downtime plan that we felt confident in and that we could afford. We really wanted to have zero downtime, but we just didn't see that as an option in our environment with the current ecosystem. So I think I know what that would look like soon. So I'm going to speak to the future of that soon. Are there any questions so far? All right. So we enforce all of these rules on our Rails code whether or not Citus enforces them. And our devs get feedback even if they run a non-Postgres or non-Citus or on a non-sharded but Citus database. And in some regrettable cases, we warn developers, but we didn't fail hard. So my recommendation is in some of these cases, you make your code fail hard if you break a safety rail instead of just warning people. We had hard rules that all of our write transactions must target only one shard, and Citus requires that. Once you've opened a transaction and written to a shard, anything else must be only talking to that shard. But we went farther and required that the shard be known, except in the case of create flows beforehand. We didn't allow any nested transactions with different tenants. Unique indices had to be removed on sharded tables unless the shard key is included in the index. Models must not have use the primary key property on their ID, but they still need to have an ID and a shard key, ID index. We also had some soft rules that we enforced with unit tests, like almost all of our new models always have a company ID, which is our shard key. We have a very small whitelist of tables that don't have that, and anybody that writes a new table will fail unless they add that. All database accesses need to specify the shard key or block or be in a block with whitelist the distributor query, or we log and we emit stats. That's a mistake. The models, again, must declare a shard key, so must the schema. The shard keys for new tables must not have the not null constraint. Must have the not null constraint unless they're a legacy table. All primary keys and shard keys need to be big int, because if we had 4-byte integers for some foreign keys and big int for other foreign keys, we know that the hash function tries to be consistent when you have IDs that are logically equivalent in both int and big int, but we didn't want to trust that. We wanted to have identical data type for everything that was going to be compared for the shard and for the hash. We required all shard key fields to have an index because we knew we were going to be looking for things by company a lot. And unique indices on the shard table had to have the shard key as the first column. These helped us identify gaps in our existing model. We rolled out these unit tests, and then we ran everything and saw where it failed, and then we saw all the gaps, and then we made our data migration plan. They also let us rest easy that future tables are going to follow the rules. We got a team, might be adding a table today. I'm going to review it, but I'm not going to be worried that it's going to be too terribly broken when I get to review it. Dynamically, we added an after save hook. This is towards repairing the shard key that was missing on a lot of our legacy tables. We added an after save hook that requires non-null values for the declared shard key. Pre-existing rows can have null. If we loaded a row and it had a null, we could resave it with the null still there, or we could set it to have a company ID, but once it had a non-null value, it could never change again. There's a similar, and this had to be done before we were on Citus. Citus won't let us have a table which is sharded on a column that has nulls all over it. It won't work. Or if it does, it treats null as the shard key, which is definitely not our intent. So now when we create a new table, it always has the non-null constraint on that column. At the time, our unit test ran against SQLite. Before I mentioned that we used to believe in Rails soft and cuddly RMDB abstraction. So our unit test ran on SQLite, but we had all of the rules that Citus imposes and then some, even when we ran against Citus, against SQLite. So that gave us a lot of confidence before we started going to our heavier environments. Okay, so here's where I'm going to start giving some code examples. How many people work in Ruby at all, or Rails? Us. Both of the teams that are going to actually migrate a little bit, so that's good news. One other person. Okay, I'll try to unpack that. I've tried to pick things that I thought were close to self-explanatory, but I'll unpack them a little bit more than I would otherwise. This is what ActiveRecord looks like when you're declaring a model, a set of models in Rails. I've elided most of the details. We have, at ProsperWorks, we have an interesting model where we allow a user to belong to multiple different customers. And early in our history, that was kind of a big deal for some of our early customers. It differentiated us a little bit. We weren't just a Saas where a company would create an account and then it would offer a dozen or 100 or however many seats to its employees or partners, and then that would be a separate seat. And a person could actually have their account tied to their Gmail account, and they could be a member of many organizations. And for freelance salespeople that might work with lots of different sales organizations, that was a game changer. They didn't have to have a separate email account for each ProsperWorks-based employer that they worked for. But that means that we have a user that doesn't shard the same way as our main tenant, our main SaaS primary customer relationship table. That table we call company, although you'll hear that called customer in a lot of sharding and Citus documentation. We also have a many-to-many relationship called company user that joins those two, where we keep track that this user is a member of these 5 companies and this company has these 50 users associated with it. It does shard in the same domain. It shards against its company ID, not against the user ID. And then I put 2 examples of cases where we were missing the direct association from some of our data model back to our table that was the core of our sharding domain. We have contact, which I've shown belongs to a company user. That means that the contact table bears a foreign key back to company user. But it doesn't have a foreign key back to company. So it didn't have something that we could identify as the shard key when we load one of them. Activity log is similar, but it's polymorphic. It has a couple of columns, one of which says I belong to a company or a company user or a contact, one of which says the ID of the thing I belong to is whatever. So again, it could belong to any of these things and did not have a direct link back to the company that it belonged to. Actually, I think in practice it did. In my example, it does not. So one of the first things we did is in Rails, we went in and we just added those links. And in our schema, we added equivalent new columns. We went to contact and added a company ID, which gave us a Rails association of belonging to company. And using some of our crawler infrastructure that we have for other purposes, we would walk every contact and transitively follow its company user to find out the company ID of the company user it belonged to, and then backfill that in. And similarly with the activity log. We crawled all the activity logs in this example. And as I recall, I had about 8 or 10 cases where I had different paths that I was crawling from one kind of a thing through different routes from table to table to try and figure out what the company ID ought to be. We also, so that was our data model, and I actually have some SQL that expands what some of these are for the rest of you who know Postgres but not Rails later. But maybe some of this was confusing if you don't know Rails. Nope? Okay. Going a little fast. We extended some great existing tools to build the next functionality that I'm going to present. We built our abstractions on a gem called Access Tenant. which I'll unpack what that does momentarily. But my recommendation to you is that you use ActiveRecord Multitenant, which is maintained by Citus. It's got some new features that have been added to it. We are on Rails 3.2, which I'm glad more of you don't work with Rails, because I'd be embarrassed if you knew what that meant. But it meant that more, we're basically outside of the support window, and we had too many ways that our ActiveRecord is not compatible with the ActiveRecord that Lucas's gem enhances. So we used an older package, backported some ideas that were interesting to us or necessary to us, and it built on top of it, and it got our job done. But that's one of my flimsy excuses for not just giving you the gem that we used for what we're about to do. It won't work with your Rails. And I wouldn't want you to be on a Rails for which it worked. So, but I think the techniques are valid and should be easy to do with the other gem. So the basic mechanism, a quick review of what Rails does for us, for those of you, most of you, that don't use it. This is not Citus, this is just Rails. Its ActiveRecord library is built on the AREL library, which is a fluent style DSL that just lets you work with sort of natural Ruby syntax to generate and work with SQL statements. So we might say contact.where name is example.first, and that expands in a pretty obvious way to the SQL select star from contacts where email equals example, limit 1. And then it'll be bundled with fetching that. It'll be bundled with expanding it into an ActiveRecord object that we can mutate things on and then later save, etc. But for the most part, ActiveRecord and AREL are this. Clean Ruby syntax that expands to SQL statements for you. They also provide a transaction mechanism where you can say in Ruby, I want this block to be a database transaction, and then I do all the stuff that I want to do in Rails, including any stupid thing I want to do, like curling out to a website, like defragging my hard drive, and then you can close the transaction, and that'll expand more or less to begin, and then the same select statement from before, and then the second line I kind of made up a has many relationship being expanded to select everything from the foo's table where the contact ID is equal to the ID of the contact that we found on the first row. And then if it fails, it rolls back. I think a lot of ORMs are going to probably do something like that for you. The only ORM I used in PHP was Doctrine, so I don't know what they do for RMDBs over there, but I suspect it's similar. Ruby is awesome in that it has coroutines like this and generators, so it's really easy for us to manage scope with pre-functions and post-functions. The syntax is probably uglier in any other language, but that's what we get from stock ActiveRecord constructs. We extended those, we made alternates to these, like read with shard ID, which was mostly just to call out to act as tenant with some extra of our own restrictions placed in it. But we would do transaction access or read with shard ID, supposing that 123 was a company ID of interest to us. We'd load the contact, and that now expands to a slightly different SQL statement. It has and company ID equals 123 injected into the SQL that would have been otherwise generated for us. Now, the effect that that has in Citus is that, does my mouse show up there? Great. This SQL statement here, oops, well, this one without the AND clause is going to go to every single shard. The coordinator node is going to take that query, it's going to forward it to every single shard, not knowing where the contact with email hi might live or how many of them there might be. N minus one of those shards, in this particular case, well, are going to, every single shard is going to give back one result, which if our emails have been managed uniquely, all of them will be empty results, and one of them will come back with the actual result. Memory and resources on the coordinator will block during the time that all of those end queries are in flight, and then the coordinator has to find the one that it actually likes and process the limits and further process the aggregations, and then it gives you the results. But with AND company ID 123, Citus says, aha, that is the shard key that has been declared for the contacts table, and I'm going to go to one and only one of my shards. So all that overhead of doing a search is reduced by a factor of the number of shards that you have in the table. That's very important. That's why you're doing it. And the syntax is actually pretty nice. And we can put arbitrarily many statements in that transaction, and they'll all get that same treatment. To save on typing, we went to a lot of really simple accessors where the ID might already be known, like if you're just calling find or save or touch or reload. Usually in those cases, you're calling that on a model where the ID is already loaded and the shard key is already loaded. So in those cases, it just sort of automatically takes care of itself. We didn't have to go to every last statement that we write everywhere and add this wrapped block. All the simple cases were handled for us. But in more complex flows, we actually did want to go in with a variety of these wrappers. So we changed everywhere we had transaction to be an explicit transaction with shard ID. Citus, again, would have required this of us anyhow, but this way we knew we had it right even before we were on Citus, which was a big asset. We also extended lots of reads. Sometimes you search for something without find. Maybe you're doing a where on some arbitrary clause that doesn't have an ID in it. So our code will tolerate that, but it'll warn about it. We prefer if you explicitly, as in the second case, oops, that's not what I wanted. Explicitly declare it, because then we'll get that company ID injected into the SQL. And then there's cases where we just have to do a distributed query. If we're looking up a user by email and we don't know what company we're looking at them for, we have to do that. Or, so we do have some flows where we decided it's okay to have a distributed query, and we don't want to log, and we don't want to stat, and we don't want to complain, and we don't want to fail, but we did want to treat that as a whitelist. So we made an explicit token that says it's okay to be distributed, which was extra work, but it means that I can now grep for all of them. Okay, also moving on to how that was the surgery that we did in Rails. I'm going to change topics. This is a good place for a question. Nope. All right. Okay. We built, as a part of our migration before, I mentioned that we had a really quick, we had a downtime window where we did a PG dump of the data only, and then we wrote a new schema into the new sharded database, which included marking all the tables as sharded. Then we loaded the dump of the data into that table. Then we ran a script that built all of our indexes again, and then we came back up. So what we really wanted was a reliable, reproducible, fast as possible script to build all those indexes, because we were running it in a time that we didn't want to be in, which was down. I have some really small notes on how we did that, but it was voodoo. I really like GNU make, and this was a throwaway task. So I built a Rails script which walked our schema and identified all of our existing indices, then did transforms on them based on what we knew we needed our new indices to be, or what we believed we needed our indices to be. And then it emitted a GNU make script that I could run with a tailored amount of parallelism. And then make called PSQL. Besides just expressing that I write overly complicated things on occasion, I wanted to highlight actually 4 key details of what we were doing with that. The first one is we wanted each one to go fast, so we set maintenance work mem to 128 megabytes, which is, I think 16 is the default. It's substantially larger than the default. That helped each individual index get built faster. We also, and this is really important, I don't know why you wouldn't want to do this, I think you should always do this, we set citus.multishard commit protocol to 2-phase commit. Building indexes is really reliable, it works really well, except this is a script that can overload it until it breaks very easily if you don't call it right. So by using 2-phase commit, I knew that once I had an index, the index was complete and valid across all shards, but it was a little bit slower to make each index. But because I was intentionally pushing the system to its breaking point to build all these indexes as fast as possible, if I didn't have that, I would have ended up with some invalid indexes that I would have had to have torn down, identified, torn down, and then rebuilt. As it was, if it fails, the index just isn't there. And what that means is we're all used to create index being transactional in Postgres. This is the distributed creation of an index. You've got the coordinator node, and you have all your data nodes hosting all of your shard databases. They're all individual PG databases. So when you create an index, it's going out to n different databases and making n different parallel indices, possibly in parallel. Well, in parallel, but not necessarily all in at once. Hopefully not all in at once. So what can go wrong is the weird statefulness of like one of those failed, but the other n-1 succeeded. And then does the coordinator like successfully go back and clean out all of the n-1, or does it wait for you to go and repair forward? All that kind of stuff. Two-phase commit is very important for this kind of script where you're going to do it aggressively. And then the next highlighted line is creating the index. This is nice and straightforward, except this is a unique index, and it's a unique index on company ID, which we are able to do because company ID is the shard key that we've declared for that table. Also, in practice, on a lot of scripts, I would probably do create index, a unique index if not exists. In this case, I wanted to drop it and then rebuild it, because if I was building it, I had some reason to believe that it was wrong the first time. So I wanted a new index, not just one only if I didn't have one. And then the fourth thing I did is that I'm highlighting is I ran this with -J5 in make, which means 5 concurrent jobs at once. That tuning parameter is important. That tuning parameter combines with the set maintenance work mem. If I ran -J100, this script would fail almost every time, because what would happen is we had 6 nodes with 64 shards. Suppose that means there's 11 databases for each, 11 slices of each table, 11 shards of each database hosted on each node. Those nodes have 64 gigs of memory, 61 gigs of available memory. If I have maintenance work mem equal to 128 megabytes, and we have, say, 80 tables, and each table has 11 shards on each node, that can multiply up to totally blow out the available memory on one of the nodes, and that's where failures will happen. So I might have wanted to have 10 gigs of maintenance work mem if I was only making one index on a simple instance and I had lots of memory and I wanted to be fast. I might want to run with 100 of these concurrently at once, because I have plenty of horsepower and plenty of CPU to build all these indexes and plenty of nodes out there. But the sort of randomness of all of these tables are all trying to make all 11 of their shards on this one node at once could just push it over the top. And I didn't have a way to always constrain it so the slices that it was making at any one time always fit within one node. So I actually spent several days on a dry run instance finding the largest safe parameters I could use. Your safe parameters will be different, but I want to emphasize that there are ways to make a ridiculous amount of indices over a really large amount of data fairly fast, but you want to be cognizant of how you can corrupt them. I would not be surprised if you guys didn't have as much challenge with this, because they now have create index concurrently in Citus 7. So if you're going to Citus 7, you're going to have a much better time. So then here's the postmortem part. Before I talk about our big failures, are there any questions so far? They weren't big failures, actually. It was a success. We're very happy. We budgeted 12 hours of downtime, which was based on some of those dry runs. And before, in the week before, we actually a couple weeks before, we set up a database. We dumped our data. We ran this process over and over and over again. We refined it. We measured it. We budgeted 12 hours, which 6 hours was for PG dump and PSQL to load that again. 4 hours was to create all those indexes on the new database, and another 2 hours for like going through and trying a library of queries and just manually making sure that things looked right. Probably we should have scripted that and brought that down to 30 minutes, but we didn't. We exceeded expectations. Everything ran physically much better than we hoped. So we were physically ready to go back online after 10 hours. But we came back online, and the coordinator overloaded and wasn't handling things at all well, so we shut down again very quickly and spent another 9 hours reconfiguring, hotfixing before we got back up. And we exceeded our budget. The first big thing, and this is my mea culpa, this is the big thing. Lucas identified and helped us fix this, but here's what went wrong. Lucas noticed right away when we were alive for that 15 minutes or so that most of the active queries that were taking up all the resources were sequence scans. And we looked back at what we had done with our indexes, and we realized that we made this mistake. Given that unique indices must include the shard key, I had replaced all kinds of indexes that look like create index, on foo bar, with create unique index on foo company ID bar, and I put company ID first. But we still had latent queries that hadn't been given the company ID that were just going to bar. So because that was the rightmost column in the index and not the leftmost column, it did not benefit from that index. So now we had important queries that had to run, because if we are creating something, they had to be valid within the unique index. They had to test the uniqueness constraint, but they had to run as a table scan too, which meant a sequence scan on all the shards. All 64 shards had to do a full scan of their table on all those nodes. And meanwhile, all the resources on the coordinator that were there to aggregate those subqueries were tied up and blocking. And all the connections to those resources from our app were blocked. So we got into a really bad vicious cycle. Lucas diagnosed that very quickly, and he had some scripts like the ones I showed earlier that he was able to roll out new queries for us. So we just basically reintroduced the first index without unique, which is no longer valid on a sharded table that sharded on a different column. But that resolved the performance problem. At least, even though we were hitting all 64 shards, it was a very quick index scan that returned very quickly, and everything got better very fast. So I call this one out because we were fixing one thing, but we didn't realize it was going to have this knock-on effect on this other thing, and I would caution you to look out for it. I think it might be an easy mistake to repeat. If it's not, I screwed up uniquely. Lucas also helped us with 2 more emergency changes. He temporarily helped us go to more than the recommended level of connections, both into the coordinator node in PG Bouncer and back out to the data nodes. Hopefully that won't be necessary for other folks. I'm just praising Lucas for being responsive and flexible with us. And he also, we had, under the circumstances, we had not chosen the largest available coordinator, so he helped us provision one with the maximum available RAM very quickly. That bought us more headroom. Meanwhile, Neil, Gerald, and Kelly on the ProsperWorks team scrambled a couple of hotfixes to go through and add copious amounts of those read with shard ID and read with shard ID and transaction with shard ID hints that I mentioned earlier. Going through New Relic and the active queries list to identify all of our hotspots, or at least the high velocity ones, and rectify them by making sure the shard ID was present. Because basically we just had way too many of those still latent that hadn't been mitigated earlier. And then there was more of the same on Monday. We have, like probably most of you, we have much, well, not if you make a game, but we have much lower traffic on the weekend, like 10 to 1, less on the weekend than we do during the week, maybe 12 to 1. So, of course, when the traffic really ramped up on Monday, we did what we could on Saturday and Sunday and felt pretty good. But new hotspots emerged on Monday morning when we hit peak traffic. We had to turn off a lot of our background asynchronous systems to make room for our web system, and it had embarrassing performance during that window. So we had another iteration of putting out a hotfix that we added more of those things to, and we got back to acceptable performance. And yeah, half a second web request is not great, but it's better than 10 seconds. And then we had some long tail things, more of the same, putting out just painting the shard ID onto flows that needed it until we had paid down all of the warnings to an acceptable level. We do have some things that we think it's still necessary in. We have some asynchronous systems that handle data en masse. So, for instance, everything that gets touched, we queue up a message that we need to update it in Elasticsearch. We have a process that does a heavy denormalization of loading a thing and everything that's associated with it, pre-processes it, and then updates it into Elasticsearch. And that thing is just one set of queues for everybody. So it's dealing with queues for lots of different company IDs. We built a company ID cache and some other things to make something that was inherently pan-customer work in a single customer at a time mode efficiently. We're also planning now, we've gained insights from this experience. We're actually going to use our existing Citus shard keys, which now conveniently enough are available everywhere, especially in our asynchronous systems. We're going to also use them as routing keys, which is the same concept. It's what they call it in the Elasticsearch world. So conveniently enough, we can just switch to using routing keys in Elasticsearch, and we expect to see a very, very large performance improvement. Be able to use a lot less hardware and have much faster queries there because of, or at least better throughput for the same reason. all of our ES queries will magically now go to only one shard instead of our 6 shards or 12 shards or 60 shards, depending on the table. We also rethought how we used PG Bouncer. Anybody using PG Bouncer? Like, yeah, you got the Rails people. Of course, the Citus people use it a lot. Josh uses it. Our model for that was we ran compute in Heroku. So we did not have an intermediate layer. We had all of our compute nodes, and then we had the database. And we run 20 to 30 workers on each of those nodes. And there's a local PG Bouncer, which used to be tuned with really restrictive pool sizes, because that was our only opportunity to defend the available connections on our database. Citus Cloud puts a PG Bouncer, makes one available. You can both go directly to your PG, or you can go through the PG Bouncer. We like going to the PG Bouncer. It puts a PG Bouncer in front of the Citus data node, as well as one between, in front of the coordinator, as well as one between the coordinators and the data nodes. So those are well tuned by PG Bouncer experts who have more expertise than we do to defend those PGs. And they are in a better position to serve as a connection pool, because all the queries are routing through them. So like all of the free connections are a reserve pool that can be juggled around among all of them. And if we've got 100 dynos, each with 20 workers that has, say, like they can only share among themselves, but here they can all share globally. So we had a realization, we had sort of a Necker cube shift in how we were thinking about it once we realized that the PG in Citus was effectively, that's 5 minutes, thank you. Oh, 10, okay. Was effectively protecting PG and maintaining the resource constraints on the connections. We switched to having a very loose permissive tuning for the ones on the dynos, because we saw no point in making a dyno block or be slowed down waiting to get into its reserve pool. And that was effective. We got a pretty good performance boost by that. So if you have more flexible infrastructure than we do, I definitely think that 2 tiers of PG Bouncer is the way to go. And the one close to the database is managing the connection resources, and the ones farther out should just be really loosey, permissive, and just be holding connections open to save on connection overhead. What went right? Really proud of this. This was logically correct. We did not find a single bug in the app behavior excluding availability problems. And we did not find a single data loss or corruption problem. Everything worked very well in terms of preserving the integrity of our application with this migration. The index fixes, thanks to Lucas, were easy to effect, and once we understood them, we were able to manage that ourselves moving forward. PG Bouncer tunings fixes were possible, thanks to Lucas. But we are already on PG Bouncer with pull mode equals transaction, so we did not have to go over the learning curve for the migration to use transaction mode PG Bouncer in order to leverage the transaction mode on the PG Bouncer in Citus. So if you're not already doing that, I encourage that. I don't know if they would be able to offer session mode or not. I'm sure they're very friendly, so you have to talk to them about it. But I don't know what that means for you, because we don't do it. Creating indexes, the speed change is a game changer. I mean, we can make indexes in minutes that used to take us hours. So the overhead and the fear factor and issues like that around new index creation, we have plenty of RAM, we have plenty of overhead. We're not worried about write performance or write throughput, worried about read throughput. And we can create indexes really fast. And Citus 7 gives you create index concurrently. Although I do have some links to some open source stuff that we offer that accomplishes something a little bit cheesier, but gives you the same effect if you're on Citus 6. We can all retire that in a couple of months, because nobody will need it ever again. But it's really amazing, because if you have all these shards, you say create index, where you used to have one giant thing creating this huge index and one giant impact, you now have 64 of them do it in parallel. I don't know if you can get the same. I'm sure you get similar perf bonuses by the parallel operations that are in PG10. But we can have hundreds and hundreds and hundreds of them. I don't know what the limit is for that. Either way, they're great. What went wrong is the overload. It was mainly driven by high RAM time product for the high velocity queries. Optimization scramble drove our downtime. I put 5 hours over budget here. I think it was actually 7 hours. We were in error. We focused on eliminating the transactions which write to more than one shard. We discounted the impact of high velocity distributed queries. I promoted with my team the faulty reasoning that these distributed resources are costly, but they're not any worse than they were in our old PG. And we're living with them now, and this PG just has more resources. So let's go ahead and just get over the hump, and then we'll go back and fix those as we need more processing time. That was wrong. They are disproportionately more impactful because of the way they tie up resources. They tie up resources down in all the data modes and really fan out the impact, and then while they're doing that, they block resources in the coordinator. So you should treat those as seriously as you treat your write operations when you're doing your migration. Also, we greedily chose citus.shardCount equals 64. I think the Citus default is 32. If I had it to do over again, I might even go off of the recommended number to a lower number like 16, because the magnitude of the mistake that we made is multiplied by that number. So we chose a larger number in the hopes that someday we can go to 64 nodes, and you know, you can't have more nodes than you have shards. And we thought, well, we're going to grow super fast, and I'd rather push an extra quarter or two down the road on when we have to actually go to a different number of shards. So we'll go to a larger number. That was a mistake, and we're not growing that fast, and it won't be. Sorry. And we don't have infrastructure for replaying live load in our prod scale offline. So we agonized over that, but we didn't like the, we could have done better faking it, but we didn't. I'm at my conclusion. You can do it, even if your app is undergoing active development. This entire time, most of our engineering team was building new features and new tables, and I think we only occupied one release cycle and one long weekend. They didn't have to really slow down. We were able to inject requirements onto them months before we migrated, well in advance, so that they had time in their schedules to incorporate that and not be too disrupted. We don't run microservices that somehow make it really easy for us just migrate one table at a time. We want a big, giant, monolithic app. And we didn't, switch to microservices just to make this migration easier. We just did it. And even most of our devs still don't internalize what it means to be sharded. We just have guardrails that tell them what the right thing to do is, and the right thing happens. We usually don't even have to worry about it in code review, although we think about it. Do not neglect your distributed queries the way we did. They won't break, but your app might. And then my final thought is, I'm really looking forward to soon when PG Logical will make it so that we can run our sharded Citus cluster as a live follower of our primary database instead of having to do an offline data migration. That would have allowed us to just run them for months side by side. We would have found a lot of problems much earlier. It would have been a lot easier to just record and run lots of queries against it and see what happens. And it would have been a live system that was undergoing the write load at the same time we were querying against it. And then our migration, instead of 19 hours of downtime, would have been a split second of a failover, and just redirecting the app to point to the new database and come out of follower mode, and voila. So that'll be a nice thing. I'm looking forward to that when it's time for us to go to 128 shards. So that's everything I've got to say. I haven't got any exciting questions yet. Shoot. Without PG Logical or something, could somebody else answer that? Is it a matter of minutes of downtime to rebuild a database of, say, I guess at that point we'd be at 180 terabytes by the time we hit. No, we'd be at half that. We'd be at 90 terabytes by the time we hit that. So however fast 64 nodes can copy 90 terabytes to 128 nodes with 10 gigabit per second Ethernet and 40% overhead.
You're doing it with PG Logical, that's true. Right now, shard splits are a manual process. So we're looking to incorporate, make that automated in the upcoming releases.
Yeah, and I believe that both PG Logical and those improvements are going to be there before we need it. And that was the thing that I wasn't embracing, was that Citus and the community are making improvements that are going to solve some of that pain before I get to that number, before I even get to 32 or even 16. We're just not growing that fast, as much as we want to. I came from Zynga, so we worry about growing virally. But I'm at a Saas, one more minute, so we grow organically. Right? We don't go from 10 users to 10 million users overnight, and I don't need to be afraid of that happening tomorrow. Yeah, it's a copy. It would, yeah.
So the other question is all the work funneled through the Cortex? Is that the only connection point?
There is a mode, which I think it's GA beta. It's in general available beta now, or maybe you've gone it's not in beta anymore. There's a thing called Citus MX that gives you enhancement in your client that it communicates more detail with the coordinator to share with it an awareness of what data is on what shards. And for some of your flows, you can go directly to the shard and just route around that coordinator. Yes, if you don't use that, all the traffic goes through your coordinator, and it is a bottleneck. But if you're not spending too much time, all your it's a bottleneck that has a heck of a lot more throughput capacity than equivalent hardware would be if it was actually hosting all the data at the same time. So it's a greatly improved bottleneck with a lot of leverage. But also, you have an opportunity to refactor your app to be a little bit more sophisticated, to share with Citus some direct links to the shards that it needs. And then where you can do that and get away with that, that'll be a bottleneck-free system. So we aren't hitting that bottleneck yet, but we anticipate doing that sometime soon in some cases. I'm at 0. Am I at 0? One more question? Yes. Yes, the question is, are we using HA? Yes, we are using the Citus failover. And I think we even had one failover. We knew there was a warning. We had a conversation about it. We decided together that we wanted to failover, but we had one failover event and it worked fine. Yes. So my understanding is that looks like, you just have your coordinator and your data nodes all have a mirror, a follower rather, and the HA is, you're paying for more hardware and for the monitoring that will promote and replace when necessary. And we absolutely use that in prod. Okay, thank you all very much. Have a good session, or have a good conference.